Okay. I should start hearing something about 3, 2, 1, 3, 2. Okay. Okay. Back to what I was doing. So I just started today with writing a little bit of notes so that I actually get this thing down. Uh, is it ABC that we call it? So I'm just typing it so that I'll memorize it because the more you type it, the more it sticks. Vec type A, vec type B, vec type C. Then is none. Returns true if scalar and or vector component is none. It is not a number if I say it's not. It's not. Returns true if scalar is not or vector is not an int. All these ones will hardly use them, but it's just good to know. Okay, is there any other stuff that we need to look at? Okay, normalize to a unit vector. Okay, let me add that. E is etc. Stuff. Then we also have things like normalize. Did I spell my normalize wrong? Yes, with a Z. So today, my plan for today, because yesterday I wasn't really happy with what I did, is to go very simple today. Actually, use since I don't want AI to be giving me the answers to like the solutions to the problems. Actually get AI involved in like the problem creation and the problem solving and let you know that okay, yes, I'm trying to actually build my skills and test myself. So I do not want the answer from it. So I just wanted to give me hints, talk about the issue with me, like talk about the problem with me, break it down into like simpler steps until I'm able to like pick up on it. So that's what I'm going to do today, and I'm going to simplify things. So I'm going to try and like do some kind of like logical statements using um our normal like functions instead of like I'll try and avoid using if statements or for loops or while statement when I can. So my plan today, I don't know whether it's actually going to be feasible, but we'll see. Is to try and do so I was doing something yesterday, gel, trying to do gel, but I'm not going to continue with that. I'm going to leave that aside. I'm going to try and do things like I'm going back to 2D, going back to the colorect. So I'm going to just try and play with. I want to play with fragment shader a lot today. So I'm just trying to play with the fragment shader, try and make different cool effects with fragment shaders. Then maybe also play with lights on the fragment shader with the normal being in this normal place. Then I'll play with the vertex shader a little bit if we then get that feel. I'll try and make things like water, try and make things like just the basic simple stuff that I'm just going to try and play with today. So that's what my plan is for today. But that's after I'm done making my notes. So we have length. I'm also during the day I had the time to like just brush up on my vector skills. So like what is normalized, what is the length of a vector, which is the length of a vector is the square root of x squared plus y squared. Let's say you have a vector x a vector Jesus Christ. The length of the vector is the length of the vector is the let me just read it from here. Ah, sure. Is the is the square root of x squared plus y squared. Just keep it like that. That's the x plus y. Then the distance of a vector is the length of vector A minus the length of vector B. That's it. So the length of a vector is the quantity of the vector without the direction, basically. Then for the direction of the vector, is I think is x over y, but I think it will not be cost or sine something. I do not I do not remember, but I saw it earlier on. I think the direction of a vector with let's say you have a graph like this. So the direction of the vector will be the direction it's pointing to. So I don't know, you can't see my mouse because I turned it off. But the direction of the vector is the direction the vector is pointing to, and I think it's just yeah, it's just logical though. Like it's just logical, like the axis is pointing to from the origin. But I think why am I thinking so much? I don't know. I'm not trying to teach right now. I'm just trying to like get things in my head because the truth is I don't understand. Let me just ask how can you find, but you're saying it's logical, like you just interpret the vector that you're given to get the direction, or you draw the vector you're given to get the direction. I think it's a formula thing. How can you find the direction of a vector? I think the one that you need to find is direction of two vectors. Let's say you have two vectors now. Okay, mathematical formula is v the to find the direction of the vector you had of a vector v, you divide each component of the vector by its geometric length. Okay, so you get the length like this and you divide it. But I'm not just normalizing the vector. The vector. Yeah, this is just normalizing. This is not really the question I asked, but like I said before, it doesn't really exist. That's why I was struggling with it. It doesn't really, what I was saying doesn't really make sense. Is the direction of the vector is just where the vector is pointing to, and the where the vector is pointing to is just like the overall this and like this vector now theory 4 is pointing to the positive x, positive y. That's just the direction of the vector. So let me return back to what I was doing. Okay, so you have distance. Distance is vector A minus vector B. So some things you will notice, this length takes only a vec A. Got to let it know. Normalize. Does normalize take two vectors or one vector? Or can it take two vectors? Normalize takes only one vector. I'm sure you can perform operation within the normalized two. Let's say you maybe want to normalize two vectors. You can perform the operation. Maybe you want them to do something else. Distance. This is vect A, comma, vect B. So tomorrow I'll also try and learn calculus. So today I am just focused on learning vectors. So tomorrow I will try and learn calculus. Dots cross the dot product of a vector and the cross product of a vector. Normally, dot product of a vector is just individual multiplication of the vector, and the cross product of the vector is you multiply it using something like that determinant matrix kind of style. Cross This is vector A, vector B. Let me just write A, B, just to be quick with it. And dots, same thing, A, comma, B. What's next? Reflect. What the heck is reflect? Reflect, refract, fix forward. I do not know what these ones are. So the determinant of a matrix, oh yeah, this is normal matrix, the determinant of a matrix is like I said before, you just not I not solve it to pen and paper, but that's determinant. Transpose. What's this? What's this? So let's ask um reflect. Think this is how you spell it. F-E, yeah, reflect. Got to let you know I'm loving how you did to me so. Baby, consider me. So I just want to just finish this. Once I'm done with that this table, I'll just go into trying to just draw simple functions. So in Godot, the reflect function calculates the reflection vector in an incident ray, like a light ray or a moving particle hits a surface and gives the surface orientation. It is mathematical function used to calculate the bounce mechanism of mirrors like reflection or specular highlights. Case for reflection. Okay, so incident vector, the normal vector. It's just okay. I think the incident would be like the direction of light, where the direction of light going towards it. So like maybe your light is it your light normal now? A straight line from your light. So like that beam goes to your object, and where the other one is like where it's bouncing out from. So Subtracting twice this value removes the incoming downward velocity component and adds it back as upward velocity. So what am I going to use this to do? Common mistake. Direction matters. The most common trap with reflex is passing the incident vector in the wrong direction. Correct. The vector must point to the surface, e.g., from the light source to the pixel. Incorrect. Pointing the vector away from the surface. Again. How do I test this? Let's see what I can test it in my flag. This country C. Could I have used reflex here? Deception. This. Looking at it, the short answer is no. Not for what you are currently doing, but you would use it immediately if you want to add light effects like specular highlight gloss in a metallic. Okay, it's for metallic material. Why reflection does not fit your current code? Right now, your primary shader is doing two jobs. Generating a normal map dynamically, normal equals complex normal, using partial derivative of a wave equation to simulate a 3D surface, like a flag or cloth waving in the wind. Coloring the fragments. Okay. The reflect function requires an incoming light direction and a surface normal, and it attributes a reflection direction. You have successfully calculated a beautiful complex number. However, you don't have a light source vector in this code yet. Importantly, you aren't trying to calculate where the light ray bounces, you just output the normal vector itself so Godot light engine can read it. Where you could use reflex in this shader if you decide to bypass Godot built-in light system and write custom light mechanics directly inside the shader. For example, adding a shiny tint or a plastic gloss to the wave material. That is exactly where reflex. Okay, so basically it's saying that I do not need reflex because, like I said, in this scene, let's see if I can open this scene. In this scene, I'm actually using Godot lights and Godot lighting system. All I'm just doing is exposing my normal to Godot lighting system, so that Godot lighting system can calculate where the light should be to the flag. So Godot lighting system is the one that's taking care of the lighting. But if I wanted to like do the lighting myself, like create a light, maybe create a light at this point, then make that light to reflect towards the flag, and like if it reflects towards the flag like this, bounce the flag towards like that, then I would use um I will use reflect. Let's look at the code it wants to generate for me. All right, the specular highlight. If you want to see a bright glossy reflection following the peak of your wave based on a fake light source, you would use reflect in your fragment. Okay, let's say I close, let's just play with it. Let's off these lights. Then let's see how this will play out. Copy. Um, how will I paste this now? Okay. Um, so okay, I'll convert this to base color instead of color. Vect or, and I'll call it the base color. Then I'm just going to paste this here. So there's no redundancy. I'm going to delete this. Then, oh, I didn't spell it correctly. Why am I spelling my color with Yusuf? Why is it always telling me it's wrong? Okay, as you can see, it created its own fake lights that or fake material lights, which is not really bad. Obviously, it also highlights, which the other system also did, highlights how ooh, it has a it's actually blends in nice with the lights, and I know that that seems kind of wrong, but it actually does blend it very well. It's just that the flag doesn't look cloth like or anything. But like if this was a particular material that was moving with this kind of wave, the glossy part is actually blending quite nice with the lights. But that aside, let's remove it. Country Z, 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 country Z. Okay. So this is where we were before. All right. Such quick review of your code math. Your math in your shader is actually incredibly clean. You are using perfect manual implementation of product, rule, and derivative to find the slope of the vector's displacement. I know. Stop deriding me. I nearly died when I was trying to figure out this nonsense. All right. I think I will close this. Wait, let me open the analytic. Because I think this is wasting my data. Yeah, close this. All right. So back to what I was doing. So that's what reflects is used for. Reflect. Then we have which other one? We have refract. In refract function, the refract function calculates the direction of ray of light passing through the boundary between two different materials like air, water, or glass in acrylic. In refract, while refract bounces a vector off its surface, while reflect bounces a vector off the surface, refract bends the vector as it penetrates the surface based on the law of optics. Okay, so what are we going to use refract now in glass, water, and wherever? So basically, I think in a 3D scene, if you want to like simulate how light will walk or like pass through an object, and you want that object to like come up as water or something, you give it a particular refractive index, and the light will bend to that stuff. Real world use keys to screen distortion. In 2D screen reading, 2D in 2D screen reading shader like glass magnifying lens or water reflow resting over your background, you can use refract to calculate exactly how to shift your UV to simulate realistic optical distortion. Let's play with this. Let's come here in the fragment shader. Let's paste. Then cut this, Ctrl X. Save this. Come here. Um, let's enclose all this. What's this? Where's my screen? Okay, it's alpha. The alpha value is too high. Why is the alpha value so high? Okay, oh no, it's rendering texture, which okay. I'm supposed to supply a texture. Wait, let me see. Resource. I'm standing with. Okay, what am I supposed to do? I actually don't understand anything about texture, but like we haven't started working with that shit, so I'll just return back to where I was before. Hmm. Maybe tomorrow I might play with textures, but today I do not have any intention of looking at textures. Um, I think we'll just sorry, we'll just leave it as it is. Let's look at face forward, copy face forward. I'm standing with the man in the mirror. Da, da. Oh my god, TikTok have spoiled my brain. Um, his name is LeBron James. I'm standing with the man of the Lakers. In Godot shader, the face forward function is used to ensure that a surface normal always faces towards the viewer of an incoming ray rather than away from it. If a polygon is double-sided, or if an object rotates dynamically, its global normal might end up pointing away from your virtual camera or light source. Face forward flips the normal vector 180 degree automatically if it detects the surface is facing the wrong direction. How it works, I would calculate. I don't care about how it works. When do you use face forward? If you are rendering a 3D flag, a piece of cloth, or a leaf of on a tree where both the front and back faces of the polygon are visible, the back faces will have the normal pointing inward when the light hits the back, and the light calculation breaks because the normal faces away from the light. Running face forward, normal in your light function instantly corrects the back illumination custom to the okay, but will this what did I use against it? 3D flag will core disable not be brighter than this forward. Mm. Which banana for brain is the classic architectural question that deals with the double-sided material like flag leaves. The short answer is they aren't competing against each other, they are teammates. You usually need render mode to make the back faces visible. Then you use face forward inside the code to make sure those newly visible bags are correctly lit. Here's exactly the difference. By default, Godot automates performance by using back-facing core. It assumes objects are solid 3D blocks, so it completely deletes/ignores the inside face of a mesh because a player should never see them. When you add render mode called disable, what it does is it tells the GPU pipeline do not delete the back triangles if the camera looks at this polygon from behind, render the pixels anyway. Limitation, it only controls the visibility, it does not alter the geometric data. The geometric normal vector of the back face is still pointing inward, away from the camera or lights. Face forward, the light fixer. The once core normal is disabled, the backside visible, you can run into light crisis if the light source strikes the back face of your flag. The mask breaks because the normal vector pointing completely away from the light source. The GPU thinks the surface is pitch black. What it does, it steps in during the fragment or light processing stage, says, hey, the cameras or light is looking at the back of this polygon right now, but the normal is pointing away. Is the normal is pointing away. Flip the normal by 180 degree so the dot product calculates the shading correctly. Sibling rival, when would you use one or the other? If you only use call this without face forward or without handling the inverted normal manually, the backside of object looks inverted, weirdly shadowed, or completely unlit when it passes in front of a light source. If you only use face forward without call disable, the GPU will or delete the back face before your shader code can even gets a chance to run those pixels. But how come my own code does not have that problem? Let me copy my code and give it to it. How come I Oh wait, maybe I actually ran into the problem, but the atmosphere is lighting up the situation. Let's open our 3D flag thing. Let's off environments. What is it? Let's how do I off it? Okay, I just click it, Abby. Now let's add the sun to the scene. So right now my goal is to make sure that the sun only faces one direction. Let's translate it to z minus 15. Zoom out. Then we rotate it. I really don't understand. The light is actually facing away from my model. So why is it so bright? Okay, let's try and make it face our model. Let's rotate it along the x-axis 90 degree. No, 180 degree, 180 degree along the x-axis. Wait, why is it darker now that it's facing the light? That's a funny effect. It's so bright without the light. So dark with the light. Or is it that my own shader code is making it emit light? No, I don't have any. I'm just giving it the normal. Or is it that I'm giving the wrong? I don't even know. I don't know. Let's let's how come I don't experience the issue with my flag and how come if I rotate the sun to face my flag directly, it becomes dim, and if I rotate to face my to face the opposite direction, it massively lights up. You aren't experiencing the black facing issue because you actually already solved this in your code. However, the string version of the sun rotation getting dim when it faces when faced directly and brightening when faced away is a classic 3D vector orientation bug. It comes down to two things. how you calculated the cross product and a subtle misunderstanding of a front facing versus face forward. When you don't experience the why you don't experience the black back face issue. Look closely at the line in the bottom. This is what happens when you don't write your code by yourself. Your code will just be having things that oh wait, the code is literally even here and I didn't look at it. If the camera looks at the back of your flag, we flip the number -1 so it doesn't turn back. SAS. Well, it's once you know, okay, this is an AI written code and this is a human written code. At the time I wrote this code, I was not ready to write this code. But right now I'm getting there. I'm getting there. Today, those are the kind of things I want to achieve today. Today I'm going to write code that every single line was written by me and everything I understand it. So that's what I'm going to be doing from now till about maybe 5 a.m. in the morning. Okay, let's return back here. All my ego now for you. The built-in front facing is a boolean that returns true if the camera is looking at a front triangle and false if it's looking at a back triangle. By multiplying your number by -1 when front facing is false, you are manually doing exactly what face forward does. You wrote a custom conditional flip. That is why your back face isn't completely black. The normal flipping towards the camera when you look at it from behind. Why the sun lighting is backward dim versus bright. The reason your lighting is inverted is because of the order of operation in your cross products. Vec, okay, normalize the inverted order. In a standard right-handed coordinate system which Godot uses, crossing the y-axis derivative into the x-axis derivative results in the number pointing backwards towards -z into the flag instead of outward. How to fix completely. To get the realistic lighting where the sun behaves naturally on both sides, you need to make two small adjustments. Step A, flip the cross product. Change the order to cross dx dy. I put my life on the line for you. Nobody else but you. Baby, 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 boo. Which line do I have in line 85? Oh, okay. All right. You see, when you do not, well, if I delete it, hope it returns cancel. Control Z, Control Z. All right. Okay, it looks different. It looks really different. And I think this is how it should look. The other time it was a little bit inverted. Let's then look at the one I posted on YouTube when I did it the first time. Although this code have actually really evolved, introducing Gemini 3.5 live translation. Gemini, I don't know, Sha. One thing I hate about this new Gemini is when you are trying to generate things that have to do with images or something that's a little bit slightly similar to image, but not really image. And it just goes ahead and generate an image for you. Like, I never said do that. I don't know, the tool calling for that image generation is just buggy. They need to fix it. Okay, so this was the flag before. And yeah, it actually had that like signs of it being a little bit, let it load now. Darkened. Actually, in fact, I think the shadows were in the wrong place, the lightings were in the wrong place compared to this one, where it's like flipped. But why does it look choppy? Let me increase the subdivision. 100 subdivision is good, though, but let's increase it to 1000. Am I trying to blow? And that subdivision increment did not really change anything. Nobody else but you. Baby, 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 boo. You know, say you be my boo. Let's turn this to 50, 50. Well, there's a big difference between 50 and 100, but the difference between 100 and 1000 is not that much. It's just mix. It's just then make my system choppy. Okay, I think the reason why it looks like this is because of the roughness value. Yeah, yeah, the roughness value. Like come here and change the roughness value. Maybe make it 5. Also, why is my whole engine actually choppy? But when shit's said and done, in a city that way, I so let's refresh. Okay. Let me bring out my charts. Okay. So that's face forward. Like I may flip my code if and use face forward instead of having my custom face forward. All right. So that's what face forward is, and okay. So what is this? Never waste your time, never let you go. We need to finish this thing before it becomes at least before 1:30 or before 1 o'clock. In Godot the matrix commox function stands for matrix components wise multiplication. Oh, matrix components wise multiplication. Unlike standard linear algebra multiplication, which calculates the dot products of, okay, if you want to multiply two matrices, but you don't want the matrix to multiply um using the row A times column A, row B times, then you use it matrix com this thing multiplication. So when would you use it? Real world use case. Maxing and modulating transform kernels. You won't use matrix for 2D positioning, but it becomes extremely powerful when processing custom mathematical grid, procedural effects, and kernels operation. Well, okay, interesting. Let's just add it to our list. So we have refract, you have feed forward, that's not you spell forward. No, I think that's how you spell forward. Wait, let me put space to be sure. I need to go back to kindergarten to learn how to spell. Yeah, let's spell this one. They have face forward and you have matrix multiplication. Matrix components wise multiplication. Then what is this outer matrix outer? Oh, I could have put it. I don't even know why I'm copying everything and putting to ChatGPT. This is another thing that ChatGPT does. It slows me down because I could have read this and understood what that actually meant. But this matrix outer product, I don't know what that means actually. Then transport of a matrix, we did that in uni or secondary school. Transport of a matrix. But like when do you use transport of a matrix? I want to do you whatever you want. When I drink from your water, give me a cup. I ain't just trying to sip. I'm trying to steal your love. I'm guilty of it. I don't give a shit. Okay, in shaders, the outer product function calculates the outer product of two vectors, while the dot product takes two vectors and compresses them down to a singular scalar number. The outer product goes in the exact opposite direction. It takes two vectors, multiplies them across each other to construct a complete 2D matrix. Wait. While the dot product takes two vectors, compresses them into a single scalar number. Eh? While the dot product takes two vectors and compresses them into a single scalar number, the outer product goes in the exact opposite direction. It takes two vectors, multiplies them across each other to construct a complex 2D matrix. Mathematic formula: if you have a column vector u and the length m, the row vector v and the of length n, the outer product u outer product v results in an m times n matrix. Every individual element. God help me. Um, outer product. Outer product of a matrix. Yeah, boring guy. Is there not just okay? I think it's YouTube short I need to watch because like I just need somebody to just perform an outer matrix multiplication. I mean, you understand? I'm looking for. Oh my god! I just need something that's like okay, okay. Watch later. This guy is good. So am I wrong? Dun, 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 dun. Okay, so that's what it means by that. You want V3. Then go to the second row again, do it again. I see, I see. I actually wrote it here. I just was too slow to catch on. But you see, this is why you need quality videos. Okay, thank you. You did a good job explaining to me. I know what transpose is, I know what determinant is. If one thing I know, so am I wrong? Yeah. Outer product and inverse. Okay, so now we can get into working today. Warm and she, yes, some say she's handsome, but you're lying. Less than, greater than, less than, equals to. These are just simple, straightforward things. Then I said I was not going to get into texture today. I used this stuff in my stuff, but like the derivative with respect to s to X window coordinate automatic gradatory. Like I really did not understand what I did there. But the reason why I was fine with it writing that code like that because I've already written and differentiated the function manually using the normal method, but I do not really understand that screen differentiation. Let's see if I can see a video on it. Maybe it will enlighten me. The F the oh my gosh, I can't even pronounce it. YouTube. I come broken to be mended. I come open to be free. I come desperate to be read. I don't know why I thought I would find something by writing that like bruv, bruv. Okay, so what we want to do today is now on to the task for today. Let's play. So I want to know, normally when you are getting introduced to mathematics, they teach you how to do this stuff like when you they start teaching if statements and logic statement, they start teaching you stuffs like they start teaching you stuffs like how to perform how will I pronounce this now? How to perform operation like maybe like find if a number is prime, if a number is even, or like maybe there's like giving a list of 1 to 100. You get what I'm trying to say. So I'm going to play with that, but with you in a way. Let me just embed data right now so that I don't run out. Okay, so I'm just back from my bank. Hallelujah. Hallelujah. Okay. Oh, kuatlah kulujaba we. Okay, let me buy 500. Just buy 500 naira. Um, do we 1 gig be enough? Let me just do 1 gig. Should be able to use 1 gig to stream relatively late today. So start theory, start 406. Who's in this world? Who's in this world? Oh gosh, I made a mistake. Come right-handed, the girl next door. Picture this, we were both butt naked. How could I? It wasn't me. It wasn't me. I need living where you come here red-handed. This you about naked. How could I? I was living in that all the time. She was never in the eyes on me. Okay, so like I said before, okay. So what I'm going to be doing is I'm going to just be trying to like um just perform those the normal like operation we perform when we want to learn programming. So when we're learning programming now, like in secondary school, uni or whatever, they'll tell you okay and find say giving a list of numbers ranging from 0 to 100, um sorts out maybe the prime numbers. And we did some things like that when we're learning programming in uni, things like that. So just kind of simple questions. So I just want to just attack those kind of questions. I want to attack. I spell attack. Uh, if we do a double T C K, I want to attack the these. I want to attack these types. This type of question or shader. Okay. Okay. Method one, the bit max lookup best for 0 to 100. Because the minimum number is 100, a dynamic primary test loop is actually overkill and inefficient for the GPU. The most shader native way to do this is to compress. Oh, I also forgot. Um, never write code for me. Just talk about the problem and give hints on solution. Okay, so we just want to play with all these things and see where it takes us. Okay, when tackling prime number identification inside shader, let me just put speaker. Let me on my system sound so that if any person is here.
Clash of architectures. Shaders are built for massive parallel processing, doing the same simple math to millions of pixels at once, while prime testing is fundamentally branchy and sequential, loops that stop early when a factor is found. To attack this type of problem without writing code, you have to shift your mindset from traditional CPU programming to GPU parallel logic. Here is a breakdown of the problem and the structural hints to solve it. The core problem: GPU limitations. If you write a standard CPU prime checking loop inside a shader, you run into two major GPU bottlenecks: divergent execution, the warp, wavefront problem. GPUs execute threads in groups, blocks. If pixel A is checking the number 7, prime, loops until the end, and pixel B next to it is checking 8, even, exits instantly. Pixel B's thread cannot move on. It has to sit idle while pixel A finishes its loop. You pay the time cost of the worst case scenario for all pixels in that group. No dynamic memory. You cannot easily build a dynamic list or an array of found primes on the fly inside a standard fragment shader to check against later pixels. Each pixel must figure out its own logic independently. Hints for the solution. Since your range is incredibly small, 0 to 100, you have a massive advantage. You don't need a heavy, generalized cryptographic prime algorithm. You can cheat using the constraints of the GPU. Hint 1. The screen space mapping. Think of your list of 0 to 100 not as an array in memory, but as coordinates on a grid or a gradient across the screen. You need a way to turn a pixel's UV coordinate, which goes from 0.0 to 1.0, into an integer from 0 to 100. Once a pixel knows its assigned number, it can run the prime test on just that single number. Hint 2. Optimize the mathematical bound. To check if a number n is prime, you don't need to check every number from 2 to n1. You only need to check up to the square root of n for a max number of 100. The square root is exactly 10. This means your loop never has to check factors higher than 7, the largest prime before 10. A loop that only runs a maximum of 4 iterations, checking 2, 3, 5, 7, completely eliminates heavy execution divergence. Hint 3. The ultimate GPU cheat, the lookup table. Because shaders excel at reading data instantly, running any loop inside a shader for a fixed, tiny range like 0 to 100 is often over-engineering. The texture approach. You can encode whether a number is prime into a tiny 10 times 10 texture or a 1D gradient array ahead of time. Primes are bright pixels. Non-primes are black pixels. The shader just looks up its value. The BMask approach. 100 bits can easily fit into a few integer variables. A single 32-bit integer holds 32 flags. You can store the primeness of all numbers up to 100 directly in hard-coded integers acting as bit masks. Then use bitwise operators to check if the bit at position n is active. Strategy for your next step. When you sit down to implement this, decide on your approach. If you want to practice math logic in shaders, use hint 2. Keep your loop boundaries strictly capped at sqrt 100, so the GPU doesn't choke on branch divergence. If you want to practice pure GPU optimization, use hint 3. Turn the math problem into a data lookup problem. Which of these two structural directions feels like the way you want to build it?
Yeah, and let's start with hint one. Think of your list as 0 to 100 as an array in memory, but in the coordinates grid. Okay, so basically what I'm going to do is that I'm going to think of 0 to 100 as 0.0 to 1.1. That's UV does X. So once a pixel knows it's assigned a number, it can run the prime test for just that single number. So basically, what I'm going to do is that if prime, I'm going to print a green color. But if the number is not prime, I'm going to print red color. So basically what I'm going to do is that I'm going to have a will mix be good now? Yeah, mix is good for it. I'm going to have a float. No, I'm going to have a vec. No, a float. Yeah, a float. No, let's have a vect. I'm going to have a vect four. I'm going to have a vect four, and I'm going to call it um p color. That's pixel color. I'm going to give it a value of mix. Then I'm going to give the first integer, I'm going to have a first vect4 again inside here. Vect4. I'm going to have the second vect4. Then I'm going to have um, a variable here. I'm going to call this variable um, is prime. Going to close this. So if it's prime is 1, we get this, we get the first value. But if its prime is 0, we get the second value. Or so. So let's call the first value. Let's just make the first value 0, and let's make the second value 1. Then let's define its prime. Its prime is a boolean. So let's say bool is prime. Can I define a boolean without I am assigning a variable to it? Wait. Can is it something like float boolean? Because in I think boolean will outfit a true or false or I boolean, integer boolean. Let me use does Godot. Let me switch to my account. This is my account. But have I worked? Okay, I'm working my account. Do Godot shader have um have a float boolean data type? I want to pass in a value of a boolean select. Wait, well, I don't even know why I'm so keen on this. Let's switch it to float first. We'll switch it back to bool if we need it to be bool. Okay. So that's it. We come here and we put the value of p color in it. And currently, how does it look? Our screen is invisible because right now everything is zero. Opacity is zero. Everything is zero. We are outputting this. I come here and put equals to 1. We output the other value. But point 0, 1.0, not 1. So so if it's prime, the pixel is colored white. If it's not prime, the pixel is colored is transparent. That first. So now we now need a way to check if a number is prime. So basically we can do UV, we can create another float numbers. These are our number list. And we're going to say this number list is equals to UV dot X multiplied by 100. So we had with this now we have all our values, but we can't this is point 100.0. We have all our values to play with. So UV times 100 is going to give us a list of all the values from 0 to 100. Because UV is wait at let me not be saying nonsense. Let me open GeoGebra calculator. Actually, it's not going to give us all the values from 0 to 100. As long as the data type is a float, this number is not going to be a solid number because UV does not output solid number. If I'm not mistaken, UV does not output solid number. UV's numbers are floating point variables from depending on our screen size. But so we need to approximate it. Or no, we need to change our screen size. I don't even know what I need to do. Because UV is a value between 0.0 to 0 to 1.0. So if the value of UV is 1.0, that pixel, that's the exact pixel in the extreme range, will be 1. Else, in the other case scenarios, if it's 0.09, the value is going to be, but we need to round it up to 2 decimal place. So UV, I'm going to round UV, round UV dot X. How do we even assign round? We want to round it down to 2 decimal place. Have I passed what I was looking for? Control F, round. Okay. Hmm. Which of them do I use? It's not the nearest integer I want. In Godot shader, let's say you want to ensure that a number is 2DP. How do you do that? How it works, if your number is this, multiply by 100 gives this, then round, okay, round will return to 0. This is a function. What is it? So hopefully, okay. So I'll just come here and create that function, round to 2dp. Then I will convert this to round to 2dp. Give it the value of uv.x. So these values are going to remain two decimal places. So now we have our list of number from, so the first decimal place is going to be, the first decimal place we're going to have is 0.00. First decimal place we're going to have 0.00. And 0.00 times 100 is 0. 0.01 times 100 is 1. 0.02 times 100 is 2. There, just go until reach 100. So that's the first thing. So that's how we're going to list out our numbers. And the second thing we're going to do is that, okay, what makes a number prime? A number is prime if and only if it can be divided by, it, it does not have any factor. That's like 2, 3, 7, 5, 11. These are number without factors. So how do you check if a number is prime? Nah, what you can do is you can divide and look for the factors, but like, how do you know if a number is prime? Check. Okay, to check if a number is prime, you need to find the factors of that number. Wait, let him confirm how to create a function to check if a number. I think we should start with even is prime. Okay, see, number is odd, number is even, the number is prime. Okay, if number is less than one, return false. For let I equals to add less than math dot square root number. Okay, I think the reason why wait, wait, how how do you how do you check if your number is prime? So would you have to check all the iteration to check if your number is prime? The most efficient standard approach is to test the divisibility by the integer up to the square root of that number. Okay. Okay, so I think what we need to do is check the odd numbers starting from theory up to roots and skipping even numbers to cut workload in half. Okay, all even numbers aside from two are prime. I mean, are not prime. Then, even two, it's and then secondly, um, you can only get if part of the number has to be less than is square root. Okay, another thing we can also do is that we can also wow. This is the first time I actually thought of checking if a number is prime. But I think I've done this before now. How did I solve it? Okay. Well, that's how you check if a number is prime. You have to actually do the long mathematics. So from this our list of numbers now. So we have to first have a function to find out if even. If even we ignore Abi. What if we have a okay. So how many okay, there's something that we need to add to this function. That's like a let's say a memory point. But we need a memory point because like 2 times 3, 2 times 3, the value of 2 times 3 is 6. 3 times 5 is 15. So when we're checking if 12 is a prime number, by that time we would have eliminated some other values. So what am I doing? Okay. Let me actually ask it. No, no, that's not. It's not print. I want a lookup. No, that's not what I'm talking about. What if we had we track operation of not prime while checking? Can this shorten our search? Like trying to verify that. Seventeen. And that idea popped in my head. Well, it's popped out of my head again. Like this is why it's being slow at typing is bad. An idea popped in my head. I thought it was a good idea, even better than this one. I think this one is a stupid idea. But now that stuff have popped out of my head. Hmm. Okay, no, it's not. But this has nothing to help me with what I want to do. Okay. So, nada de. So what am I going to do to a number that's a GPU friendly? I think I can just come and copy this because I don't think there's any way I can use GPU friendly to do that. Is one not a prime number? Okay, it has to be greater than one. So okay, for one is zero. I'm gonna stand. My people winning together. How do I check? Okay. So I can just come and use this for loop here. Okay. So let me just write it myself. I can just come here and say for bracket open. No. How did we even write that stuff again? For how do you write for loop? For number in range uh, how do you let me go back here and see how they write for loops. How do you write for loop in this language? Sef? Previous. Or int I in okay. Let's copy this. Then we'll go here and edit it. For numbers numbers number plus 2 why can't I write this square root? Okay. I think I'm not thinking of for loop so correctly. What is a for loop? A for loop is a loop that will run a certain amount of time unless a condition to break out of it is, and this condition was uh, I don't know how to write normal for loop. Cannot write normal for loop. I know that what we'll do is a mod num. I know here we are square. mm, Something like this. I don't know exactly what we're going to do. This is the worst logic I've ever seen in my life. Okay, basically, we need two conditions to break out of the loop. That is, one, we haven't found the if is equals to zero, we break out of the loop. Else, we continue running the loop. I need help. Fix the early return. Right now, your function ends with return zero. Okay, so what right now we're seeing float I is equals to the square root of number. No, let's say I is equals to 3 actually, because we're going to start checking from 3. Oh no, let's say I is equals to 2. I is equals to 2. And I is less than the square root of number. But no, ah, shit. Okay, let's go back to this operation. We first check this. I think this is the main reason why. So now we can safely make this 3 and add 2 on every iteration to keep it odd, because we have checked if for all the even cases. I'm bad at coding, but I'll get better. There was a time I was good at this thing. Or at least this kind of like low level coding. So if the mod of the number is equals to 0, break. Is this correct? One, two, three, four, five, six, seven, eight, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Ah, that means I'm wrong now because I got 22 stripes. Two, four, five, six, with one, two, um, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. I got 22. I am not. Okay, wait. These are logic now. Okay. Theory divided by we don't even run. We I don't think we ever run. If we start I from one, what happens? Why did we draw the one line? Okay, when number equals to three, we come here like this. For the first one, we set I equals to three. Then we check if I is less than 10, which it is less than 10. Then we increase I by oh god, I'm dull. Mm. Why did I even do this? If? Like, what was my purpose of doing this? Well, I wanted to finish achieve my goals without using AI. Okay, we're checking if okay, I'm doing something very wrong, which wait. Why am I doing floats? We need to turn this into ints. Int 3, I less than 10, I plus 2. Oh my god. Oh. Never mind, I'll find someone like you. Okay. Right now, the shade only cares about the UV dot X, the horizontal axis, because you are completely ignoring UV dot Y, the vertical axis. Whatever happens at a specific horizontal point in screen stretches all the way from the top of the screen to the bottom, creating a stripe. Here is a meta model to think or hints you need to reshape to into a grid without touching code. The core problem mapping 2D space to a 1D index. To build a 10 by 10 grid, you will need both UV.X and UV.Y. Okay, so the first thing I want to do is that I want to just try and build a 10 by 10 grid. So instead of dividing just x axis into 100 parts, you will need to divide both the x and y into 10 parts each, total of 100 squares. Role and role identity. Every square on your screen will have a coordinate pair like an Excel sheet or a chessboard, a column number of 0.9 and a row number from 0 to 9. The fattening formula. So your prime function expects to a single um, sequence number of 0 to 100. You need a formula to take care of row and column. Hint: break x and y into 10 by 10. Your current code multiplies uv.x by get a grid. Your column needs to go from 0 to 9. Okay, so what I can do is that I can come to this column, remove this. Wait, before I remove the column, let me create the function. Say vect, vec, No, I can say floats, grid, and make it equals to UV dot x. That way, then I can multiply UV dot x by 10. Then do the same thing. So call this grid x loads grid y, and we just do the same thing but in the y axis UV dot y multiply by 10.0, and that's for our y axis. Then I need a way to tell it's kind of like, okay, so wait, 10 times 0, 10 times 0.1 is 10 times 1 is 10. So, my brain is not comprehending. What's going on here? Why am I so dull? Your UV code multiplies. Okay, I want to alternate the painting. Okay, close your eyes and try and visualize this thing. You have a graph sheet. A graph sheet. Let's look at the negative as now. You have a graph sheet. You have 1 1. You have 2 2. You have 3 3. You have 4 4. You have 5 5. You have 6 6. You have 7 7. You have 8 8. Okay, we need a way to alternate. We need a way to alternate like every interval. So how to know in an interval? How to know one, 2, 3, 4. It's not coming to me. It's not coming to me. This thing did not even help at all. But let me maybe it's because I didn't read properly.
To turn your vertical stripes into a grid of squares, a 10 times 10 box layout, you need to move from 1D spatial mapping to 2D spatial mapping. Right now, your shader only cares about UV, X, the horizontal axis. Because it completely ignores UV, Y, the vertical axis, whatever happens at a specific horizontal point stretches all the way from the top of the screen to the bottom, creating a stripe. Here is the mental model and the hints you need to reshape this into a grid without touching code. The core problem, mapping 2D space to a 1D index. To build a 10x10 grid, you need to use both UV, X and UV, Y. Grid segments. Instead of dividing just the x-axis into 100 parts, you need to divide both the x-axis and the y-axis into 10 parts each. 10 times 10 equals 100 total squares. Row and column identification. Every square on your screen will then have a coordinate pair, like an Excel sheet or a chessboard, a column number from 0 to 9, and a row number from
I'll be with the Lord while the edges run, while the edges run, while the edges run. Okay, I think I can just do something like this. Create a function. Let's make it a float for now. Um, let's return row, and let's row be equal to 1.0, while the edges roll on, while the edges roll on, gets row. I'll be with the Lord. And that row is going to take in the value of number, while the edges roll on, gets number, while the edges roll on, goes. No. If num is if number is less than greater than or equals to number row times 10 while the ages roll on. While the ages roll on, I'll be with the Lord. While the ages roll on, while the ages, while the ages roll on. Where do I define rowing? That to not be destructive. Through the valley of sin, I don't want no. I'll be dug by the day. 'Cause I'll be with my Savior while the ages run on and on and on. While the ages roll on, while the ages. So basically, we're saying if number greater than or equals to row times 10, row plus equals 1. So we increase row by 1. So then we return the value of row. Why are we returning the value of row? What do you want to reuse the value of row to do? So that's how we know which row we are in. Now we already know. Oh my god, I'm doing this search in so wrong way. But anyhow, sha. So now we need to tell this place that it's going to paint. If we set color equals to uv dot x, while the ages roll on, while the ages roll on, I'll be with. 'Cause I'll be with the Savior while the ages roll on and on, while the ages roll on. Okay, the main reason why we are painting the way we are painting is that prime is changing for every value of UV dot x. So for every value of UV dot x, it is prime or it is not prime. That's how we're painting that distance. So this is prime variable is what we are trying to try and glitch. Now, if maybe we wait, what kind of check is this? I'm checking if number, which is a number between 1 and 100, is less than or equals to row times. Listen, which row is a number that is going to be incremental number that whenever row times 10 is more than number, we increase row. So for row 1, when number is less than 10, if row is greater than, this also be less than now. If number is less than, let's check this first. Control C, Control V. I on track. Yeah, you definitely consensual with wanting to calculate a row based on number. However, the current implementation have a few bugs that will cause compiler error or slightly break the logic. Let's break down why get row approach isn't working yet and how to simplify the whole process using directive mapping instead of working backward from a 1D number. The get row function bug. Look closely. Okay, yeah. This get row is too dependent on get column. So this get row is for input variable. It's supposed to take in UV dot um UV dot Y. That's what it's supposed to be as input. I'm going to save it as the current row. Cause I'll be with my savior. Why the ages roll on, and why the ages roll on, why the ages roll on, I'll be with. Then I can have a second function like this to say get column. I'll be with Lord. Control X. I'm going to say Control V. Get. I don't know why my app stop headed. But you told me that what I'm doing is wrong. the ages roll on. We are not supposed to be setting this colon multiple times. We're supposed to use a uniform variable to set it, or at least set it outside here. Can I set a float here? Float equals to with colon comma is equals to 1 comma. Okay, let's dump this idea. So we're going to um, remove this first because we don't need this. Um, we're going to remove this. What the heck? Oh, sorry. Okay, we're fine now. Say create a column and we create a column by multiplying. I created these two things, but like it didn't click in my head. What next? My brain couldn't comprehend what next. She goes like mm. Okay, let's just do what they asked us to do. Sha. So let's create cool. Let's create a float. Call it cool, and let's set it to the value of uv dot x. Why am I so slow in typing? When will I increase in speed? I've been typing for how many years now? I need to go and start taking all those typing tests too alongside this nonsense I'm doing. uv dot y. Uh, I think I inverted it, but it doesn't matter. Okay, I didn't invert it. Then once you have an integer like column, okay, we're supposed to multiply it by 10 like we did the last time. Multiply by 10. Instead of rounding to 2 dp, we'll round to 1 decimal place. So we'll collect this from this country, right? I don't know what they were trying to say. So if, once you have the integer and column, next step, look at how you handle uv.x in the fragment function. Instead of doing that, try reconstructing your fragment logic like this. Create a flat column using uv.x scaled by 10.0. Use floor to help you round down. Okay. Um, let's call these. Wait, let me understand that in way before I go. Create a float column using. Okay, I've done this. Create a float row. We create a float column using uv.s scaled by 10. Okay, rounding and flowing or flowing it. If we round the number, let's see, Control F round. If we round the number, we go to the nearest integer. If we float the number, we round to the nearest lowest integer. So they say we should floor it. So we don't really need this. Instead, we come here and we just open a bracket, and we just floor this. Do the same thing for here. Floor. But it gives us an integer, which is a invalid argument. Suddenly, those good old days are gone. 10 years. Instead of doing that, try reconstructing your fragment logic like this. Create a float column using uv.x scaled by 10. Use float or rounding helpers adapted for a 10 step grid. Why would we floor it? Oh. Okay, I think we need to do this with a second variable. Come here and let's create an integer and let's call this column I, and we're going to just floor column. Let's call this int uh, row I, and we're just going to floor row. Let's not forget our semicolons. Then let's not also forget to make this a float. Wait, I don't get. I can do this. That means I can do this now. Yo, Sars. What the fuck is wrong with you? I don't need this. Okay, now from here now, what did you not say I should do next? It said I should calculate the float number by multiplying row by 10 and adding your column. Okay. Then pass the freshly calculated 2D number into your existing get prime function. Wait, where's the number now? So we'll remove this as the definition of number. Multiply um, multiply row by 10 and add column. I can use FME to do that. Multiply row by 10. So that's row, comma, 10, comma. Then we're going to add colon. Our number is, if we did that correctly, dun 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 dun. Dun 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 dun. Dun 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 dun. I know, bro. Sneaking in the FMA. I'm a genius. I need people to be learning today. We learned how to use this shit. Dun, 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 dun. Because of how the shader works, let's okay. If you load this right now, you will see a beautiful, perfectly spaced 10 by 10 matrix square. Your parallel prime checker logic is completely solid, but you are likely seeing one final visual quirk. The grid feels like it's upside down, reading in the wrong direction. I didn't even look at the grid. I just looked at, do we have grids? This is not even correct, safe. Wait, one, I can't even count it at this point. Dun, 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 dun. Hint, if you want a bottom up grid, you want it to look like a traditional match chart of a classic 1 to 10 board game, starting at 0 at the bottom and counting up. When row is equals to 0, the top corner of the screen, you want it to act like 9. And when, okay, and to do that, you just, in this island, baby, let me in. Go here. Easy on me, baby. I was just a child. I didn't get the chance to feel the world around me. Babe. I was scared to lose. Okay, country C. Let's then give to the other one to mark me. I know, right? It's like using. Oh my god, I'm a genius. Ah, ensures the grid reads naturally from bottom to top like a graph or top to bottom depending on the coordinate preference. There is one tiny logical oversize on how the grid sides are rendered. If you look closely at your output, every single grid looks like a solid color, but they don't have distinct borders separating them because the math maps every pixel inside the block. Yeah, here's an hotel code adding a tiny bit of vector math to inject a symbol grid. Yeah, I think this is a good addition to the code. Where did he do it in? How the math breaks down. Bottom level, UV times strips the whole number away, giving us a mini 0 to 1 coordinate space inside every. Okay, instead of using. Wait, no. Okay, so we assign the color, then he creates a vector, then he puts UV in vector and multiply by 10, then does a frac of it. So for one, two, three, four, five, all of them, for each of them, he assigns a border thickness, creates a step function. Oh my, this would have been an interesting thing for me to solve on my own. Anyhow, though, to have solved this and I've seen it. So solving it again would be just wasting my time. Okay, now that we have this border, I can confidently beat my hand in my chest and say, this shit is wrong. Like, at what point do we have prime numbers? Like, where is one, where is two? If you start from here, one, two, wrong. If you start from here, one, two, wrong. Like, where are we starting from that is correct? Let's remove the flip. Let's see whether if we remove the flip, it will be correct. Contract. Still wrong. One is not a prime number, two is a prime number. Mean that at least in one side of our cube we should have green, white, but we don't have that, meaning that this stuff is wrong. Dun, 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 dun. Country A, country C. I don't know where, but the logic is wrong. If 2 is a prime number, then second box should be white. The core problem, how core problem, index 0 versus human counting. When you are looking at the bottom row of your screen, your eyes naturally count the box from left to right. Box 1, the far corner, box 2, the next, box 3. But look at your math formula. It's calculating from bottom left of the screen. At bottom row equals 9.0. So 9, so box 1 far left equals 0, not prime. Box 2 equals 1, green, not prime. Box 3 white. Okay, so it's saying that it's the third box that should be white. Okay, white. Okay, this is so this 1, 2, 3, 4. Wait, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, I was not counting 0. Oh, oh my god, my back. I need a chair that can be raised to my back while I'm typing. Oh, Jesus Christ. Oh, Jesus. Damn. Okay. Okay, let's save this as, let's rename this shader. Save as prime number. So now we can clear all this and start a new problem again. You have some limits to everything popular is that your optimization choice inside the shader were incredibly clean. You have mastered 2D mapping, loop, unrolling limit, and coordinate flattening. Let's step to up the difficulty. Here are three interesting problems that forces you to stretch your shader math skills in different directions. Pick one and make that makes you go, how would I even do that? The snake grid. Right now, your grid read left to right on every row 0 to 9 and 10 to 19 and then 20 to and 29. This means when you reach the end row, the number awkwardly teleport back to the left side or for the next row. Goal: make the number flow continuously like a snake or a snake that ladders board game. What's snake and ladder? I've actually been hearing about this snake and ladder board. Like culturally, I don't know what it is. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so it's growing like this, it's growing like this, it's growing like this, it's growing like this, growing like this, growing like this. Okay, so how do we make our board look like that? Okay, did they give us any hints? Why is this fun? It forces you to manipulate your column calculation based on whether the row index is an even or odd number completely without using an if state completely without using an if or else statement using pure maths operation. I didn't think of using that, so I just thought of flipping. Wait, let's look at how we go about it. So currently, right now we're seeing um row. We're multiplying row by 10, then we're adding column. Let me write it out. Let me open GeoGebra calculator. GeoGebra.org calculator. Start calculator. So currently now we have our row. Row is equals to, let's say, 1, column is equals to 1, and then what is this A? Then we We have the what do we call that variable? The number is equals to row times 10 plus colon. So if is that not our equation? Row times 10 plus colon. So on the first iteration, let's make this a slider, create slider. On the first iteration, row is equals to 0, column is equals to 0, and when we multiply by 10, we get 0. When column is equals to, now I don't know how GPU moves, but I think that's an interesting question. Does GPU move row 1, colon 1, row 2, colon 2, or does it move row, colon, row? Like, how does it count? How do the GPU counts UV? Is it instant or is it per row or per colon? Like row first or colon or moving through the colon. To understand how GPU process your UV coordinates, we have to look under the hood on how modern graphic engineer. The short answer is it doesn't go row first, it doesn't go column first. It processes thousands of pixels across the screen completely at the same time in parallel. However, because GPU hardware are bundled with specific hidden pattern to how it moves, massive parallelism the massive parallelism, the instant illusion, when the shader runs, the GPU doesn't use CPU style loop into the pixel, blah, 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 blah. Okay, so basically, we are increasing both values at the same time. We're not really increasing. Okay, this is the thing. This is why looking at it like this does not really make sense because it's not actually increasing like um row equals to 2 column equals to 10, but we can use this to get a good idea sha. So when row is so let's be clear, I trust no one. You did not break me. I'm still fighting for peace. And I got thick skin and an elastic heart. Okay, so right now, I want to make it count in a row. I mean, I want to make it count like instead of counting that it will jump to the other side. I want it to count straight like this, like the snake and ladder counting. So how do I manipulate this formula that how do I manipulate this formula that at row equals to at row equals to if I say 10 equals to 1 and column equals to wait, let me count how many boxes we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0. Okay, so sorry. Uh, at row equals to 0 and colon equals to 10. The next thing, when row switches to 1, we do not jump back to. I'm overthinking the question without thinking how to solve it. We do not jump back to this edge here. Instead, we are here and we start counting towards this side. Now, eh, basically, it's to flip it in a way, just the way we flipped. I feel like if we flip it just the way we flipped the row, it will work. So what do we need to flip? Okay, for each row, we need to flip the column. I think that's what we need to do. For each row, we need to flip the column. Why this process you to manipulate column? Then the calculation based on whether the row index is even or odd number completely without using if statement. Using pure okay, there's this function that I saw that time. Let me see, even. There's this function, even. Around to the nearest even integer. No, that's not what I'm looking for. Okay, I think that's just the even function. Okay, to know if a function is even, you use a mod operator, yes. Uh, but why? Jesus. I'm struggling. I'm struggling. This should be obvious to me, but it's not. And it have given me the answer using pure math operation like mod. One to 9, 10 to 19, 19 to 29. How will we do that? UV is the reason why we are returning back there. UV is the reason why we're returning back there. So how do we not return back there? Mm. Okay, what we can do is okay. Wait, while you visit, while we're returning back there, I thought of something just now, but it's not going to work. That is manipulate the number, but not manipulate the number itself. Instead, it's if we are not manipulating above here. I think here is fine. It's from here downward that we need to manipulate. So we need to know what line we are on, and if we are on for each of the interval, we need to lie to ourselves. Yes, we need to lie to ourselves. So if it says it's prime, we'll say it's even. But if we say it's even, we'll say it's prime. If I say even. If we say it's prime, no. That's not going to work. No. So I've flipped UV before. I've flipped UV by just minusing UV. That literally flips UV. What happens when we do minus? So dull. Control Z. So I was thinking what happens if we have minus column. Nothing. So why can't you comprehend this simple thing? Like, what's so difficult in this thing for you to comprehend? Now you are just here moping. You're not even having any idea that even come out as intelligent. You are just having foolish ideas. Hmm. But I think we should talk more about it, sha, because I have spent how many hours moping on it. Let's talk more about it. Talk more about this problem. Talk about John inside Jerusalem. This is an absolute classic of problem because it exposes the core philosophy difference between looping CPU versus calculating. Crazy part is that I cannot just stop this in CPU. A snake game is trivial. You write a nested loop and keep a global counter variable that an if statement. If the current row is odd, count backward, else count forward. But in the GPU, Pixel doesn't know what happens before them or they don't know what happens next to them. Every pixel executes its code completely isolation. A pixel sits at the right edge of row 1 has to look up at its coordinates and independently deduce I am on an odd row. I must flip my horizontal value, but I calculate my index. And to make it true, shader challenges to make it a true shader challenge, doing it without if or else branching keeps your execution speed basically bla- blazing fast. Even read self I cannot read. Visualizing the mathematic mirror. To solve this, you have to think about what counting backward actually means mathematically. Let's look at the column for any given row. They naturally go from range 0 to 9, left to right. And on row 1 even, you want column 0 to mean 0 and column 9 to mean 9. On row 1 odd, you want column to mean 0 and 0 to mean 19. You want column 0 to mean 19 and column 9 to mean 10. If you strip away row-based multiplier plus or minus for row 0 and what am I reading? Let's slow down. If you strip away row-based multiplier plus 0 for row 0 plus 10 for row 1, you can see that on odd rows, the column direction is completely mirrored. Let edge column equals 0 need to act like it is the right edge 9. Right edge 9 needs to act like it is the left edge 0. Two mathematical weapon you need. To achieve this without branching, you need to combine two distinct mathematical concepts using fragment pipeline. Weapon 1, detecting oddness safely. You need a mathematical way to switch the output to 1 if the row is odd. Wait. The shader in shader the reverse. If the row is odd, you need a manual way to switch the output A1 if the soldier is odd. If the what am I reading? You need a manual switch that outputs A1 if the row is odd and A0 if the row is even. You already know that the tool for this the module operator percent for integer and mod for float. If you take row percent 2, the output strictly alternates between 0 for row 0 to 4 and 1 for row this. Weapon 2 interpolation mix as a gate. In the shader, the mix A-B weight function is your best friend for eliminating if statement. If weight is 0, mix returns A. If weight is 1, mix return B. If you plug your row parity in a weight, you can seamlessly choose between two different column value based entirely on whether the row is even or odd. What I cannot read, like my brain is too, it's reading from his brain. If you plug your row parity in as a weight, you can seamlessly choose between two different column value based entirely on whether the row. Okay, so you can use a mix, use -9 and use a modulon to solve the problem. To calculate the parity, figure out if the column row is even or is odd. Create an alternative reality. Calculate the column value. Rosas, deep breath in, deep breath out. Deep breath in, deep. So that. Let's return back up. So the first thing we want to do is we want to detect. Okay. Rosas, you are not thinking. And that's the issue. You're not thinking. You're not thinking. Hey, another day will come again. Weapon 2, linear interpolation, mix as gate. In shaders, the mix. Okay. I didn't even look at what we drew. However, the flip math has a subtle logical error that will cause your odd row to move out negative numbers or drop out your intended 0 to 99 range. Let's trace the math to see exactly what's happening under the hood. Math breakdown, tracing your current logic. Let's look at what happens on row 1, which is the odd row. So C is equals to 1. Your mix function runs mix 0, comma minus 9, comma 1, which makes flip equals to minus 1. Now look at the far left box in where column equals 0.1. Your FMA calculation becomes Somebody help me. When I was praying, praying to my Father, somebody touched my soul. Somebody touched me. Somebody touched me. Somebody touched my soul. When I was praying, praying to my Father, somebody touched my soul. Let's go. Somebody touched me. Somebody touched me. Somebody touched my soul. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it's wrong. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Very wrong. 10, 11, 12, 13. Okay. When I was praying, praying to my Father, somebody touched my soul. Somebody touched. Okay, row one. When okay, let's see. Row one is 0. Ah, somebody save me. Hmm. I wake up in the morning, then I hear boom, I'm in trouble. What exactly am even the row and column is confusing my brain. Let's give it to Mark, even though it's wrong. When I was praying, praying to my Father. Still wrong. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Usas. You need to quit coding. It's not for you. It's not for you. It's not for you. It's not correct too. 0, 1, 2, 3, 4. Wait. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or is it that I'm not passing in the right file? What file am I editing? 2D test. The shader, what shader are you using? Because that is not correct. Oh my god. No wonder. If I were to come here and switch the shader, no wonder I was not even able to get a feel of what exactly I was doing wrong. Because I wasn't just seeing anything changing. Load. 2D test. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. Hmm. More at this point now, I'm writing the code, but still the AI that's solving the problem. I'm still unable to solve problem. I'm still unable to solve problem. Right now, I'm just becoming better at writing shader code, like actually writing shader code. But like to know the code to write is an issue. And this was not my problem before. My problem was to write the code was an issue, but I knew the code to write. But now it's I don't like this new problem. Like right now, I can't even write say okay, I want to write pseudo code to solve a problem because like I can't even write pseudo code because like I can't even comprehend the problem. Tell neighbor sandbox, learn how to use back buffering. Wait, let's go back up to see what's the problem is. Okay, cellular automata. Instead of a visualizing a static math property, make the grid alive and change over time. Goal: build a shader where every cell save as snake and ladder prime. Instead of visualizing a simple static math property like prime, make the grid alive and change over time. The goal: build a shader where every cell checks its eight surrounding neighbors. If a green cell has exactly three white neighbors, it becomes white. If a white cell has too few or too many neighbors, it dies, it turns green. Why is fun? It introduces you to texture sampling, frame buffers, back buffers. Okay, now let's talk more about this problem. Let's Maybe it's because I cannot read, that's the issue. Let's talk more about this problem. When I'm solving physics questions normally, or like I'm solving my normal engineering question, why I usually like to do that, I usually like to read the question twice. Read the first time, get an understanding of the question. Read the second time, bring out my data and draw my diagram before I solve. I need to be able to look at these questions like that. Welcome to the world of cellular automata. Moving, let it read to me. Level of frustrations are
Welcome to
high.
the world of cellular automata. Moving from static math properties to Conway's game of life is a massive rite of passage in graphics programming. This problem completely flips the script on how you use shaders. Up until now, your shader has been stateless and mathematical. The color of a pixel depended entirely on its current coordinate and nothing else. But game of life requires memory and state. A cell cannot decide its next state unless it knows what its neighbors looked like in the previous frame. Because a shader can't store global variables from frame to frame, you have to exploit a classic GPU technique, using textures as memory. The core concept, the simulation loop. To understand how a GPU calculates cellular automata, you have to understand the render loop, feedback loop. Instead of treating a texture as just an image you look at, you have to treat a texture as a 2D data grid. The read step. The shader reads the state of the grid from the previous frame, stored as a texture. The logic step. For every pixel, the shader looks at its own color, samples the 8 surrounding pixels, and counts how many of them are active, white. The write step. The shader writes the new state, green or white, to the screen for the current frame. The feedback. The current frame is captured and fed back into the shader as the input texture for the next frame. The core problem, texture sampling mechanics. To make this work in Godot, you have to shift your thinking from screen space grid math to texture sampling. 1. The neighbor offsets. To check the 8 pixels around you,
I
you need
think
to
we're
sample the
offline.
texture at different
I've lost
offsets.
power.
If your pixel is at coordinate u, v, your top left neighbor isn't just u1, v1. UV coordinates always range from 0.0 to 1.0, regardless of how big the texture actually is. If your simulation grid is 100 times 100 pixels, the width of a single pixel in UV space is exactly frac 1, 100 equals 0.01. This value is called the texel size. To check the cell to your left, you have to look at U, text, texel underscore size. 2. Godot's secret weapon, screen underscore text.
Shit, I was not listening. I don't know where my brain was. Let me just try and solve this question. I'm quite a day. I will not solve the next one. Let's try and be quick though, because I don't have enough time. I have 98%. What's the estimated remaining? Estimated 1 hour and 40 minutes. Okay. Um so basically what it's saying is that we want to let me ask whether I understand the question. So we want to store the UV data, the UV color data of last frame, then check our grid with its neighbors to see if, wait, what was this question? Wait, okay, read step. The shader reads with game of life. The problem completely flips the script up. Oh gosh. Go build a shader where it checks every eight surrounding neighbor cell. If a green cell has exactly three white neighbor, it becomes white. If a white cell has too few or too many neighbor, it dies. Turns green. Okay. If a if a green cell has exactly three white neighbor, it will turn white itself. But if the cell has too few, if a white cell has too few neighbor, it turns green. Okay, so we want to store the UV color data of the last frame. Check our grid with eight neighbors of each cell. Convert cells with three white neighbor whites and convert cells with many green. If its white cell has too many or too few or too many neighbors, it dies, it turns green. Cover cells with many whites, that's more than three whites or no, you or no white neighbor. My spelling is just terrible. Green. The spelling was so bad, the dictionary cannot be corrected. Exactly. You summarize the core rule of the game of balance. It's self it depends entirely on the magic number of neighbor. To actually build this into a Godot shader, you have to tackle two distinct phases: the infrastructure, the feedback loop, and the sampling logic. The let's break down how you can attack both steps without looking at the final code. Phase one, up memory. The Godot infrastructure, because standard canvas item like a sprite 2D or Canva color rate clears their pixel every single frame. A basic shader can't look back in time. We need to create a texture that saves what we draw. In Godot, we have two awesome ways to achieve that. Approach one, sub-viewport buffer, the professional way. We create a sub-viewport node in your scene tree and place your color rect with your simulator shader inside. You set the sub-viewport update mode to always. Okay, wait. You create a sub-viewport buffer. You create a sub-viewport node. Okay, let me create that. New sub-viewport. Make the color rect a child of the sub viewport. Um, custom 100, 100, copy. Said, what do we do? We create the sub viewport. We set the update mode to always. Where's the update mode? Is it render target update mode? Okay, we set the update mode to always. You create a second sprite outside the viewport display. You create a second sprite or canvas item outside the viewport display that displays the sub-viewport texture. Wait, what? What's even going on here? You create a second sprite or canvas item. Okay, that means we're going to have two shaders. Okay, let's decrease the second color rate. Okay, what next? Inside the shader, you create a uniform 2D. Okay, so Ctrl C. Lesson file, load shader file. Um, to the we're just going to come to the top here. We're going to assign this value. Go to viewport, texture, run logic. Oh god, I want to complete this now, boy. I can't. I can't. I can't. I'm tired. I'm exhausted actually. Uh but we are not quitters. We're not quitters. Okay? This is too small, I can't see it. It's one guy that is doing me like this. I've not eaten. Let's see. Alright. So the back buffer. Godot has a built-in node called back buffer copy. If you place a back buffer copy node in your scene directly above your shader material, Godot takes a snapshot of the screen right before the shader runs and stores it in global buffer called. I've never heard of this back buffer copy. We'll have to read on this. I'll do that off stream. Uh, so why didn't I create a color rect? Wait, I don't even know. I don't even know what's going on or how my scenario is supposed to be. Back buffer copy create copy mode rect. Okay, if you place a back buffer copy node on your screen directly above your shader material, Godot takes a snapshot of the screen right before the shader material is called. Your shader can then read from the screen texture to see the grid. This is I'm going to cheat, obviously, but tomorrow I'll work on this later today after I wake up from sleeping, and tomorrow we'll work on it because it's an interesting concept, but it's a concept that I cannot solve. I have lost power supply, so um, um, a time limit and will not be able to figure it out today, but I don't want to leave this question solved. Give me the node tree structure I should have with the setting and attached script. So beautiful. Let's okay. So game of life, just a node or a control. Okay. Simulation viewport, sub viewport container. Okay, so I have my sub viewport container there. My sub viewport container should hold a sub viewport and a color rect. Wait, there's a difference between sub viewport and sub viewport container. This is a sub viewport. So I need to create a sub viewport container. Add a charge sub viewport container. And as a charge of it, I put this. What am I doing? Sub viewport container. Sub view. Okay. Full screen. Critical node setting. Make sure to configure this setting in the inspector or feedback loop will remain blank. Sub viewport setting. Size. Set the desired simulation resolution. 100 for sharp 10. This is inside of the sub viewport. Now 1000 by 1000 is better. Okay. Disable 3D check on save massive GPU memory. Clear mode set. Set this to never. Clear mode set it to never. Update set it to always. I've done that. Color rect layout. Um, set to full rectangle. Perfect for to feed the sub viewport. Okay. Create a new shader material and paste the code inside. Okay, material shader. Let's attach the load to the shader. Load is a shader parameter. Okay. Then attach the script directly to the game of life. Why did he make such a mistake? I cannot write the functional code block for you, but is since your power is back, you are ready to assemble. My power is not back. I say write the code for me. All these step one. Before doing anything, check the simulation. Okay, I think the first thing I need to do is come here, delete everything. Then float. Sorry. Okay. So we have this clean function. Now the first thing we want to do is before any math, Shader has to check if the simulation have already started on the very first frame. Your previous frame text is completely blank. Strategy, look at the color of your previous frame text at UV. Um, Control V, Control A, copy, Control V. I'm cheating, but like open. Hmm, it's not going to do it today. I have to figure it out. So tomorrow I will just I'll read this code later and figure out what it means. There's no light right now, so I'm trying to be quick. And I'm actually very stressed right now. This was going to be, well, I will solve it again, sha. I've not even been reading the code, so solving it again will still be a new experience for me. But this was going to be like a challenging one that was also putting me on track. But I don't know, I'm not just in the right frame of mind and NEPA decided to take light. Hmm. The error is plenty. Stop doing this nonsense now. No, I want this thing to blink before I off it. Let me use Actigram thing. Some few minutes less. 3 minutes, man. Um, New conversation. Uh, Create project. Add folder.